Hi everyone, my name's Joshua and this is a collision-based audio system built with Unreal Engine and Wwise. Before we get into it, let's hear how it sounds. With this project, I wanted to expand my knowledge of sound implementation using Unreal Engine's blueprints and Wwise to create a system that accurately represented the interactions of physics objects in-game. Priority number one, of course, was to make something that sounded good. That's why we're here after all. Priority number two was to make a system that was reusable and easy to iterate upon without having to start from square one if changes needed to be made or new assets created. First, we'll look at the blueprints to see how the physics data is collected and interpreted, and then we'll dive into Wwise to have a look at how the sounds are put together. Each of the physics objects in this project are inherited from a parent class. This class is set up with an empty static mesh component and an attached AK component. The parent class has a set of functions and macros which are used by each object, which we'll discuss in detail shortly. I use macros for events requiring more than one execution input or output, but since they can't be inherited, they're actually stored in a separate macro library. A number of variables are declared in the parent class for use later. The motion group consists of data about the motion of the object in play, while the curves are used to scale the raw data into a more usable format for Wwise. The relevant Wwise events are set in the child blueprints. In the child blueprint, the relevant static mesh is added to the static mesh component, and a slightly larger collision shape is attached to that. If the static mesh is the right shape to roll, we set the canRoll variable to true. On event begin play, a random flow is used to set the randomizer RTPC in Wwise, which slightly changes the pitch of all the relevant sounds so that each instance of an object doesn't sound exactly the same. Now with everything set up, we can look at the system itself. Every time a hit is registered using onComponentHit, all the relevant motion variables are set with a function. Following this, hits under a certain velocity are ignored, and then the blueprint casts the player character to check if it's currently being held by them. At the same time, the collision shape is setting the value of a bool on begin and end overlap, letting us know when the object is close enough to another actor to be considered touching it. Once a hit has been registered and we've checked if the item is currently held, either the impact held or unheld macro executes. The impact held macro sets the impact velocity RTPC on the AK component based on the scaled velocity length of the object, and then posts the play impact sound event. The macro begins with a do once node, which is reset by the friction macro. This prevents the impact sound repeating every frame if it's held against another actor. The impact unheld is the same basic premise but with a couple of extra steps added. First, we check if the other actor in the collision is currently held by the player, and if so, we do the same trick as before with the do once node, reset by the end overlap event. Then we use the dot product of the impact normal and the normalized velocity to get the angle of impact, ignoring it if it's too close to perpendicular. The final, most complicated part of the puzzle is the friction macro. This requires the event tick, although since this can be very expensive, we've used a timer event to limit its execution to 20 per second max, with 50 milliseconds interpolation times on the RTPCs to smooth things out. First, the macro checks if the collision shape is overlapping another actor, and then sets the friction velocity RTPC with the scaled velocity length, then checks if it's currently held by the player. If it is, we can ignore the object's angular velocity, but if it's not, we need to check if the object is rolling, which will trigger the play rolling event, or spinning, which sets the rotation velocity RTPC and then posts the play friction event. If the shape is not overlapping another actor, the stop events are posted instead. Each of the play and stop events are gated by a do once node, which is reset by the inverse event, allowing us to avoid multiple unnecessary triggers. Finally, the stop events reset the do once node on the impact held macro. And that's it for the blueprints. Let's have a look at how these sounds are put together in Wwise. So we've got 3 collision parameters, which are set by the data coming in from Unreal, and 1 randomization parameter, which is set on event begin play. Each of the objects has its own dedicated friction play, friction stop, and impact event, and the ones that can roll, in this case the bottle, has the rolling play and stop events as well. The impact sound for each object is produced by a blend track containing 4 random containers, each containing a collection of impact sounds at different levels of force. The low, medium and high tracks are crossfaded between based on the impact velocity RTPC, while the top track is an extra transient layer added at the highest levels of impact velocity. The friction sound for each object is another blend track consisting of 2 looping random containers, a high frequency and a low frequency element. The high frequency element is a single granular loop, giving us a consistent sound, while the low frequency is a concatenated series of individual sounds to provide some textural variety. The combination of these two allows for a sound that is relatively realistic, but still able to respond to player interaction. The volume for both is controlled by the friction velocity RTPC, but the higher sound has a much steeper fall off. Additionally, the rotation velocity RTPC is used to affect the amplitude and speed of an LFO, which is connected to an EQ peak, which mimics the frequency variations you hear when an object starts spinning on the ground. Lastly, the rolling sound is simply a random container with volume controlled by friction velocity. And that's my implementation of physics-based audio in Unreal and Wwise. Thanks for watching.